Imagine for a moment that everything you see, touch, and move through is a trick. The chair beneath you, the room around you, the horizon that seems so far away. All of it framed by three familiar directions: forward and back, left and right, up and down. We take these axes for granted because they form the cage of our experience. We live inside this box, convinced that reality is built upon it. But what if this sense of solidity is not the foundation of existence, but only a thin shadow of something deeper? What if dimensions themselves, the scaffolding we believe reality hangs upon, are illusions? This is where the question begins. It sounds absurd, almost reckless. Of course, space has dimensions, you say. We measure them every day, whether in the length of a road, the height of a building, or the depth of the ocean. But physics has a way of shattering the obvious. What we perceive is not always what is real. And the further science has pressed into the nature of space, time, and matter, the more slippery this notion of dimensions becomes. Are they physical? Are they emergent? Or are they nothing more than human tools, convenient descriptions mistaken for truth? For most of human history, the assumption was simple. The world exists in three dimensions of space. Aristotle spoke of length, breadth, and depth. Euclid formalized them in geometry. It seemed unquestionable. The ground beneath our feet, the objects we build, even the heavens we charted, all bowed to this trinity. It was common sense, but common sense, as history shows, often cracks when we push against the unknown. Think of the earliest explorers who looked across the ocean and saw only endless water. Common sense told them the Earth was flat, that sailing too far might send them tumbling into the abyss. Then came the revelation of a sphere, a globe, a higher reality that common sense had blinded them to. Dimensions may be the same. What feels like certainty may in fact be confinement, a prison of perception that physics has begun to escape. And perception is indeed a prison. Our eyes, our bodies, our very evolution tuned us to a particular slice of reality. We see in three dimensions because our survival depended on judging depth, distance, and direction. Predators hidden in grass, prey moving across the plain, shelter and horizon. The brain stitched vision into space, and we inherited the illusion of solidity. But as soon as you descend into physics, you find that space is not so solid after all. Consider the atom. Its electrons occupy what we call orbitals, but not like planets circling the sun. They are clouds of probability smeared across space, regions where the electron is more or less likely to appear. The neat edges of length, width, and height blur into fuzz, go deeper into the quarks inside protons and neutrons, and even these seem less like particles in space than vibrations in a deeper field. The scaffolding of dimensions feels increasingly like a stage set, useful for us, but indifferent to what is actually being performed. But the most unsettling question is this: what if dimensions aren't there at all until we measure them? Quantum mechanics already whispers that reality does not exist in a definite state until observed. Does the same apply to dimensions? Are they a canvas stretched behind the world, or a painting brushed into existence only when we look? This is where the hook of our story sinks in. The familiar, the ordinary, the three-dimensional comfort of life is not guaranteed. It is an assumption, and assumptions have a way of collapsing under the weight of discovery. Imagine walking through your city, the skyscrapers rising like pillars into the sky. Now imagine being told that the very space they rise into is not fundamental, that the three axes you navigate each day are emergent, fragile, provisional. What would that mean for the solidity of your world? What would that mean for reality itself? Because here is the paradox. Physics has already shattered the three-dimensional comfort zone. Einstein showed that time is not separate from space, but bound into it, forming a four-dimensional fabric called spacetime. That was the first fracture. Time, once thought to be a flow apart from space, was revealed as just another coordinate. If time could be reimagined, why not more? Why stop at 4? And indeed, in the century since Einstein, the frontier has exploded. Theories like Kaluza-Klein, string theory, and M-theory have proposed 5, 10, even 11 dimensions, not as fantasy, but as necessities demanded by mathematics, hidden folds of space that might explain the forces of nature, the birth of the cosmos, even the possibility of other universes. So we begin the descent. We begin in the ordinary world of 3 dimensions and 1 time, comfortable, simple, intuitive. But already the cracks are showing. Already the whispers of something deeper have reached us from the far side of understanding. And this descent is not only scientific, it is existential, because to question dimensions is to question reality itself. If the stage upon which everything is played is not what it seems, then what certainty remains? What does it mean to live in a world where the floor beneath you may be no more real than a shadow? This is the frontier where physics meets philosophy, where science becomes indistinguishable from myth. For we are like prisoners in a cave, staring at shadows on the wall, convinced they are the whole of existence. But what if the shadows are projections of a greater reality? What if our 3-dimensional lives are echoes of dimensions beyond? 12,000 years ago, human beings carved stone circles at Göbekli Tepe, trying to bind meaning into permanence. Today, we carve equations instead, binding space and time into mathematical form. In both cases, the same hunger drives us, to understand what we cannot see, to touch what we cannot grasp. Dimensions may be our greatest monument yet, a way of framing the infinite with symbols, of pulling the ineffable into form. But are they real? Or are they stories we tell ourselves, shadows that vanish when the light shifts? This is the question we must now face. It is not comfortable. It will not let us rest in the 3-dimensional certainty of daily life. It drags us into Flatland, into Einstein's spacetime, into string theory's curled dimensions, into the holographic whisper that our reality may be an illusion. The descent has begun. The seeker has left the ordinary world, and what lies ahead is darker, stranger, and more transformative than we dare imagine. Because if dimensions are not real, then what is? The call to adventure often begins with a story. For dimensions, that story is Flatland. Published in 1884 by Edwin Abbott, it was a satire on Victorian society disguised as a parable of geometry. Yet it became something far more enduring, one of the most haunting thought experiments ever written about the unseen nature of reality. Flatland imagines a world of 2 dimensions, a plane populated by lines, triangles, squares, and circles. These beings live and move within length and width, but know nothing of height. They cannot look above their world any more than we can step outside our own universe. To them, reality is complete. To them, depth is inconceivable. And yet Abbott invites us to imagine a 3-dimensional being visiting this plane. To the inhabitants of Flatland, such a visitor would appear supernatural. They would see only a cross-section, a circle as the being passed through their world, never the full figure itself. For us, this is a fable, but it is also a mirror. Are we not Flatlanders in our own way, convinced that the 3 dimensions we move through are complete? Yet what if, just as Flatlanders cannot imagine height, we cannot imagine the higher dimensions that physics suggests? Abbott's tale is not only a piece of satire, but a warning. It whispers that our perception is not the limit of reality. Here lies the call to adventure. It demands we confront the possibility that what we take as solid truth is only a slice of something larger. And science, in its slow, relentless way, has taken up this call. By the late 19th century, mathematics itself had already begun to slip beyond the confines of human intuition. Thinkers like Bernhard Riemann and Charles Howard Hinton explored the idea of higher dimensional spaces. Riemann's geometry bent Euclid's flat, rigid shapes into curved manifolds, the very groundwork Einstein would later use for relativity. Hinton wrote of the fourth dimension with startling seriousness, treating it not as fantasy, but as a plausible extension of mathematics. These visions unsettled the imagination. Newspapers of the era speculated on invisible worlds. Artists painted strange, fragmented forms inspired by geometry. Mystics seized the language of higher dimensions to describe realms of spirit. For ordinary people, it was both thrilling and terrifying. If there were higher dimensions, then what else lay hidden, brushing against us like a Flatlander's circle, glimpsing the passing of a sphere? But the most provocative seed in all of this was not mathematics or mysticism. It was the hint that physics itself might require higher dimensions to make sense. The world of forces, gravity, electromagnetism, seemed incomplete when confined to the familiar. And soon that call to higher realms would draw even the most cautious scientists toward what seemed unthinkable. We must pause here and reflect on what it means to hear this call. To imagine extra dimensions is not just to extend geometry, it is to challenge our trust in perception itself. Everything you believe to be solid, everything you believe to be certain, rests on the scaffolding of three-dimensional intuition. To step beyond is to risk vertigo. It is to admit that our species may be blind to the very structure of reality. And yet, once the idea takes root, it is impossible to shake. For consider this, if Flatlanders were real, their physics would be incomplete. They would puzzle over why certain forces appeared inexplicable. They might infer through shadows and distortions that something larger was pressing against their world. They might build theories of an unseen third dimension that none of them could perceive. Their call to adventure would be unmistakable. They would have to follow it. We are no different. Our physics too has run into puzzles that resist explanation within the walls of three-dimensional space and one dimension of time. Unity between gravity and quantum mechanics. The mystery of dark matter and dark energy. The stubborn refusal of the standard model to resolve its gaps. Like the Flatlanders, we glimpse distortions, anomalies, missing pieces that suggest something larger pressing against us. We cannot see it directly, but we feel its effects. And so the question sharpens: is our world complete, or is it only a shadow of higher dimensions? If we live in Flatland, who are the spheres passing through our world, casting fleeting signs that vanish as quickly as they arrive? The call to adventure is also cultural. Throughout history, humans have imagined hidden realms, heavens, underworlds, spiritual planes. These were metaphors born of myth. But what happens when physics itself begins to hint that such realms might exist in literal form? Not of angels and demons, but of additional coordinates woven into the fabric of the universe. The overlap between myth and science blurs. The mystics spoke of higher worlds. The physicists began to whisper of higher dimensions. Both pointed towards something beyond. But not all calls are welcome. For every thinker thrilled by the possibility, there were skeptics who dismissed dimensions as abstractions, useful for equations but not for nature. The refusal of the call looms, the insistence that what we see is what is real, that talk of hidden spaces is fantasy. That refusal still echoes today, and it is powerful, but the story is already in motion. Physics is already pulling us forward. The dimensions will not be silenced. Here, in this second step of our journey, the ground beneath us begins to tilt. We feel the vertigo of possibility, the sense that we may be Flatlanders staring at shadows we cannot understand. The call has been sounded. Higher dimensions are not fantasy, not myth, but a scientific question of profound importance. The call to adventure is never comfortable. It is an intrusion, a disruption. It drags us from certainty into doubt. But it is also irresistible. Because if we dare to follow it, if we dare to imagine what lies beyond, we may discover that reality is far stranger, far deeper, and far more magnificent than we ever believed. And so the question remains, echoing across time and mathematics, whispered through parables and equations alike. If there are higher dimensions, why can't we see them? What hides them from our view? That is where the journey must take us next. Every great journey is met first with resistance. When the call to adventure sounds, the instinct is to turn away, to retreat into the comfort of what we already know. And so it was with dimensions. For centuries, the notion of higher dimensions was treated with suspicion, if not outright derision. To the skeptic, such talk was philosophy at best, mysticism at worst. After all, dimensions are not abstractions to us, they are the framework of existence itself. To question them is to question the solidity of reality, and for most of history that was a step too far. Ancient thinkers drew the first lines of refusal. Aristotle declared that the universe had exactly 3 dimensions of space, because that was all it needed to be complete. Length, breadth, depth, nothing more, nothing less. To add another was unthinkable. Euclid, whose geometry would dominate Western thought for 2 millennia, codified the world in terms of 3 dimensions, building his axioms upon them like bedrock. The idea of a 4th, 5th, or higher coordinate was simply absent. Even when mathematicians in the 19th century began to whisper about higher spaces, the scientific establishment was skeptical. Yes, you could construct algebraic systems that described 4-dimensional shapes. Yes, you could write equations for a cube extended into another axis. But what did that mean? Was it anything more than a trick of symbols? Equations are not reality, critics insisted. They are tools, not truths. And so the refusal hardened. If dimensions cannot be observed, they do not exist. This skepticism was not unreasonable. Science, after all, is meant to be grounded in evidence. If a theory strays too far into abstraction without experimental anchor, it risks becoming metaphysics. And what could be more untestable than a dimension we cannot even see? The very word dimension was tied to the physical world, to measurable extension, to the distances we could walk, the volumes we could enclose. To imagine one beyond perception seemed to many like science fiction. Yet history shows how dangerous skepticism can be when it calcifies into dogma. The earth seemed flat because no one could imagine otherwise. The heavens seemed immutable until Galileo's telescope revealed their imperfections. The refusal of higher dimensions carried the same flavor, an insistence that what is visible must also be all that is real. And yet, cracks in that refusal had already begun to form. Mathematics would not be silenced. In the 1820s, mathematician August Ferdinand Möbius introduced the idea of 3-dimensional transformations that hinted at higher orders of symmetry. In 1854, Bernard Riemann shattered Euclidean complacency with his lecture on geometry, revealing that space itself could be curved, pliable, something more than the rigid stage of objects. Still, the refusal lingered. Beautiful mathematics, yes, but surely the real universe was simpler. Surely space was only 3-dimensional. But the skeptic's wall stood for deeper reasons than science alone. Higher dimensions threatened philosophy itself. For if there are realities we cannot perceive, what does that say about the reliability of our senses? What does that say about truth? It is one thing to be told that the Earth orbits the Sun. It is another to be told that your very experience of space is incomplete. It is to be told that you are a prisoner of perception, a flatlander blind to a larger world. For many, that was not science. It was an assault on certainty. This is the nature of the refusal, the human impulse to cling to what we can touch, measure, and see, to reduce reality to what fits within our hands. And yet, the refusal always cracks, because reality is not bound by what comforts us. The tension deepened in the late 19th century. Hyperspace became a fascination for mystics and artists as much as for mathematicians. Charles Howard Hinton coined the term tesseract to describe a 4-dimensional cube. Writers speculated about beings who could move in directions we cannot comprehend, appearing and vanishing at will. Spiritualists adopted higher dimensions to explain ghosts, visions, and the afterlife. To serious scientists, this mingling of mathematics with mysticism only strengthened the refusal. Dimensions beyond the third, they declared, were fantasies, suitable for parables and poetry, but not for physics. Yet even as skepticism hardened, physics itself began to falter under the weight of its own questions. Why did gravity resist unification with other forces? Why did light behave as both wave and particle? Why did space itself seem woven with mysteries no three-dimensional framework could resolve? The refusal of higher dimensions grew brittle. Reality itself seemed to be demanding more. But we must linger here in the refusal to feel its power, to imagine how radical it was to suggest that dimensions, the most fundamental aspect of existence, might be incomplete. To understand how difficult it was to accept that our perceptions might be inadequate. Without the refusal, the later breakthroughs would carry no weight. Without resistance, the call to higher dimensions would have been trivial. And so the skeptic's wall stood imposing and immovable, 3 dimensions, no more, no less, a world bounded by length, breadth, depth, and nothing beyond. That was the creed of certainty. That was the foundation of reality. But foundations can crack. And in the early 20th century, one man would deliver the first hammer blow, showing that dimensions are not fixed, but fluid. That time itself is not a part, but a dimension intertwined with space. That the refusal was only a temporary shelter against the storm of truth. Einstein was coming, and with him, the dimensions would never be the same again. Every great journey needs a guide, a mentor who transforms doubt into vision and reveals the path that lies hidden. For the story of dimensions, that guide is Albert Einstein. His work did not merely expand our understanding of the universe, it shattered the walls of perception, revealing that even time, the relentless river we thought unshakable, was not what it seemed. At the dawn of the 20th century, physics was approaching crisis. Newton's clockwork universe, with its absolute space and absolute time, had held sway for centuries. It was a model that explained falling apples, planetary orbits, the motions of tides. But the cracks were showing. The speed of light measured by experiment seemed stubbornly fixed no matter how the observer moved. The equations of electromagnetism resisted reconciliation with classical mechanics. Reality no longer fit within the old dimensions. Then came Einstein. In 1905, with his special theory of relativity, he proposed something audacious, that space and time were not separate entities, but 2 aspects of a single fabric. The dimensions of length, breadth, and depth could not be understood without weaving in time as a fourth. The river of seconds and minutes, once thought to flow uniformly for all, became relative, stretching or compressing depending on motion. Space and time, once absolute, had become elastic. To grasp this was to encounter the first true mentor in our story, a vision of dimensions that refused to stay confined to intuition. Imagine 2 observers, one standing still on Earth, the other traveling at near the speed of light. Their measurements of time disagree, their rulers stretch and contract, and yet both are correct, for reality itself accommodates their perspectives. What we call dimensions are no longer rigid coordinates, but pliant, woven threads of a single fabric called spacetime. The implications were staggering. If time is a dimension, then past, present, and future coexist in a block universe. A 4-dimensional whole where every event, from the birth of stars to the fall of civilizations, already has its place. To us, time feels like motion, a flow from what was to what will be. But relativity suggests otherwise. Time does not flow, we do. We move through the fabric of space-time like Flatlanders, tracing a path they believe to be all there is, unaware of the larger shape that contains them. Here, Einstein plays the role of mentor not only in science but in philosophy. His theory forces us to step outside perception and see the world from a higher vantage. He whispers to us, "You believe in 3 dimensions because that is all you see. But the universe cares nothing for your senses. It is larger, richer, stranger. But Einstein was not finished. In 1915, with his general theory of relativity, he transformed the mentor's lesson into something even more radical. Space and time were not only woven together, they were malleable. Matter and energy bend space-time, curving it into valleys and ridges. Gravity, long imagined as an invisible force pulling objects together, was revealed as geometry itself, the warping of dimensions by mass. A planet does not circle the sun because it is pulled by an unseen tether. It moves along a curved path in the fabric of space-time, like a marble rolling around a dimple in stretched cloth. A black hole is not merely a massive object, but a tear in this fabric, where the geometry becomes so steep that not even light can escape. What we experience as the strongest of forces is in fact the bending of dimensions beneath our feet. Think about what this means. Dimensions are not static coordinates, like lines etched on graph paper. They're alive, dynamic, responsive to energy. The universe itself is not a stage upon which matter plays. It is part of the play, woven with matter into a single performance. In this revelation, Einstein became the mentor who showed us that dimensions are not only real, they are the very grammar of reality. But his mentorship did not stop with geometry. Relativity also whispered at deeper mysteries. If space-time could be curved, then perhaps it could also be extended, folded, or hidden. Perhaps the familiar four dimensions were only a fragment of something larger. In this way, Einstein prepared the ground for the call beyond, hinting at higher structures his own equations could not yet reach. And yet, as with any mentor, his teachings carried both illumination and danger. For relativity solved some problems, but left others unresolved. It explained gravity with breathtaking elegance, but left electromagnetism apart. It curved space-time, but could not explain the quantum world bubbling beneath. It united dimensions, but also deepened the question: are these four all there is? Or are they the visible surface of something more? Here, the mentor does what all great mentors do. He sets the seeker on the road but does not carry them all the way. Einstein revealed space-time, but he also left us with riddles. His lessons invite us forward but demand we confront the next threshold ourselves. To this day, relativity remains one of the most tested and confirmed theories in science. GPS satellites correct for time dilation predicted by Einstein's equations. Light bends around galaxies, producing cosmic lenses that map dark matter. Black holes, predicted as mathematical curiosities, have been photographed by telescopes spanning the Earth. The mentor's words endure, written into the very functioning of our modern world. And yet, as we stand at this point in the journey, we sense the incompleteness. If space and time can be united into a single-dimensional fabric, why not more? If gravity is geometry, what is electromagnetism? What of the strong and weak nuclear forces? The mentor has opened the door but not crossed it. The refusal of dimensions has been broken, but the full truth still lies ahead. And so we leave this stage with the echo of Einstein's voice in our minds. Dimensions are not what they seem. They bend, they stretch, they unify, they weave together the ordinary and the extraordinary. They are not the floor upon which the universe stands, but the fabric from which it is made. But this revelation is not the end. It is only the threshold. Because if 4 dimensions can be real, then what about 5? What about 10? What about a reality so vast, so strange, that our 3-dimensional lives are only the faint shadow of something greater? The mentor has guided us this far. Now the seeker must cross into realms even Einstein did not live to see. Every story of discovery has a moment where the seeker crosses the threshold, leaving behind the comfort of what is known and stepping into the unknown. For dimensions, that moment came not long after Einstein had revealed space-time. The world had adjusted, however reluctantly, to the idea of 4 dimensions, 3 of space, 1 of time. It was strange, unsettling, but the equations worked and experiments confirmed it. Reality had expanded, but perhaps it had finally reached its limit. And then in 1919, a German mathematician named Theodor Kaluza posed a question both audacious and disarming in its simplicity. What if the universe had not 4 dimensions, but 5? Kaluza was not chasing fantasy, he was pursuing unity. At the time, Einstein's general relativity elegantly described gravity as the curvature of spacetime, but electromagnetism, the force of light, electricity, and magnetism, remained separate. 2 pillars of physics, both powerful, yet seemingly unrelated. Physicists longed for a single framework that could contain them both. Kaluza's leap was to imagine an extra dimension of space, one so small and hidden that no one had noticed it. In his equations, this 5th dimension did something astonishing. It generated the mathematics of electromagnetism. Out of geometry itself, light and electricity emerged. The union was breathtaking. Gravity and electromagnetism, long estranged, could be understood as different aspects of curved geometry in 5 dimensions. It was the first glimpse of a deeper order, and it came from daring to cross the threshold. But the idea, as elegant as it was, seemed impossible. If there were a 5th dimension, where was it? Why could we not see it, touch it, move through it? The refusal of higher dimensions still loomed, and critics dismissed Kaluza's proposal as beautiful but unreal. That is when Oscar Klein, a Swedish physicist, extended Kaluza's vision with a new idea. Perhaps the 5th dimension was real, but hidden, curled up so tightly that we could never perceive it directly. Just as the surface of a garden hose appears one-dimensional from far away, a line, yet up close reveals a circular dimension around its thickness, so too might the universe contain dimensions beyond our sight, coiled into scales smaller than atoms. This was the threshold itself, the realization that reality could be richer than perception, that dimensions might exist unseen, hidden not by absence but by scale. Our senses and instruments were too crude, like flatlanders staring at a line and failing to notice its subtle curvature. Imagine it, a universe of hidden corridors, compacted spaces folded into every point, dimensions we cannot enter but which shape the forces we feel. Gravity, electromagnetism, even the possibility of other forces yet undiscovered, all encoded in the unseen architecture of higher dimensions. Kaluza and Klein had given physics a new language, and with it, a new frontier. The threshold was crossed. But as with all thresholds, what lay beyond was not comfort but ordeal. For decades their ideas lingered at the margins, admired for elegance but doubted for lack of evidence. No experiment could probe such tiny scales. No direct observation could confirm hidden dimensions. The scientific establishment, cautious and practical, filed Kaluza-Klein theory away as a clever curiosity, a mathematical trick without proof. Yet the seed had been planted. The thought could not be unthought. If one hidden dimension could unify gravity and light, what might more dimensions achieve? What mysteries might dissolve if we allowed ourselves to imagine 10 or 11 or more? The threshold, once crossed, never lets the seeker return unchanged, and the implications ran deeper than physics alone. Philosophically, the idea was staggering. If dimensions exist beyond perception, then our picture of reality is woefully incomplete. We navigate a world of 3 dimensions as if it is all there is, but in truth, we may be like ants crawling on a sheet of paper, blind to the space above. What we call reality may be nothing more than a thin slice of a larger whole, a shadow of hidden depths. Even Einstein, cautious as he was, could not ignore Kaluza's equations. He admired their elegance and explored the idea himself. Though unconvinced of its physicality, he saw in it a glimpse of the unity he had long sought. The mentor had led us to the threshold, and Kaluza and Klein had stepped through it, carrying the vision further. And here we encounter one of the great paradoxes of science. Sometimes the most beautiful ideas lie dormant, waiting for the tools of another age to awaken them. For Kaluza-Klein theory would slumber for half a century before resurfacing in the strange, ambitious mathematics of string theory. But in that dormancy, the question took root in the minds of physicists and philosophers alike. If dimensions can exist beyond sight, how many are there? What role do they play in shaping the forces of nature? And most unsettling of all, if we cannot perceive them, can we ever truly know they are real? The seeker has crossed the threshold. The world of three-dimensional certainty lies behind us. Ahead stretches a labyrinth of hidden corridors, curled geometries, and unseen scaffolding. What we once thought of as space is no longer simple. It may be folded, compacted, multi-layered, rich with structure beyond perception. But every crossing comes with a price. Beyond the threshold lies uncertainty, confusion, and trial. The journey forward will not be easy, for if dimensions are real, they will not reveal themselves without struggle. They will demand new mathematics, new experiments, and perhaps new ways of thinking altogether. And so, we step into this hidden landscape, aware that the floor beneath our feet may contain more than we can ever know. Kaluza and Klein have opened the door, and through it we glimpse both promise and peril. A universe that is not three-dimensional, not 4 but perhaps 10 or 11 or more. The seeker has entered the labyrinth, the tests await. Every journey through the unknown requires allies, companions who help the seeker endure trials and glimpse truths that cannot be faced alone. In the story of dimensions, those allies come not in flesh and blood, but in mathematics, in theories so vast and intricate they seem to shimmer with their own life, and chief among them is string theory. For decades after Kaluza and Klein's daring step into 5 dimensions, their vision lay dormant. The scientific world had little appetite for unseen spaces that could not be measured, no matter how elegant the equations. Physics turned instead to the quantum realm, to the electron's mysteries, to the nucleus, to the strange zoo of particles uncovered by accelerators. But unity, the dream of a single framework binding gravity and the quantum together, remained elusive. Einstein died chasing it. Generations pressed forward, but the puzzle resisted. Then, in the latter half of the 20th century, string theory emerged. It began humbly, as a mathematical attempt to explain the strong nuclear force, the glue that binds quarks into protons and neutrons. The equations described vibrating filaments, tiny one-dimensional strings whose oscillations gave rise to the particles we observe. But what began as a niche model grew into something far larger. For in the mathematics of strings lay the potential to unify all the forces of nature: gravity, electromagnetism, the weak and strong nuclear forces, within a single elegant framework. There was, however, a catch. Strings only made sense in more dimensions than we perceive. Not 3, not 4, but 10. Later refinements in M theory suggested 11. These dimensions were not optional extras, nor decorative flourishes. They were required by the equations themselves. Without them, the mathematics collapsed into inconsistency. The seeker had acquired a powerful ally, but one that demanded a steep price: the acceptance of realities we cannot see. To make this vision less fantastical, string theorists borrowed from Klein's old idea of compactification. The extra dimensions, they proposed, are real but hidden, curled up at scales so small they escape detection. Imagine an ant crawling along a garden hose. To us, from far away, the hose appears as a one-dimensional line. But to the ant, close enough to perceive the surface, the hose reveals itself as two-dimensional. It can move forward and back, but also around the circumference. Likewise, we see the universe as three-dimensional because our perspective is limited. At subatomic scales, however, additional dimensions may coil within every point, as real as length and height, yet invisible to our senses. And these hidden dimensions, according to string theory, are not arbitrary. They shape the very properties of our universe. The way they are curled, the geometry they take, often imagined as intricate Calabi-Yau manifolds, determines the particles and forces we observe. Change the shape of the hidden space, and reality itself changes. The universe as we know it may be only one possible configuration among countless others, each determined by the architecture of dimensions beyond sight. This is both exhilarating and disquieting. On one hand, it offers a breathtaking unity, all of nature's variety distilled into the vibrations of strings moving through multidimensional space. On the other, it suggests a multiverse, an infinite landscape of possible realities, each with its own laws, its own constants, its own physics. Our universe may not be inevitable, but simply one outcome among many, chosen in a sense by the folds of dimensions we cannot perceive. But are these dimensions real, or are they mathematical ghosts, beautiful but insubstantial? This is the trial the seeker now faces. For while string theory has captivated generations of physicists with its elegance, it remains untested. No experiment has yet confirmed the existence of extra dimensions, nor the strings themselves. The mathematics is seductive, but mathematics can deceive. Allies may guide us, but they can also mislead. And yet, dismissing them outright is too easy. The power of string theory is not only in what it explains, but in how it reframes our questions. It shows us that dimensions need not be limited to what we see, that geometry itself may be the engine of reality. It challenges us to imagine a universe whose scaffolding is richer, stranger, and more intricate than perception suggests. Think again of Flatland. To its inhabitants, the possibility of up would seem absurd, yet we in 3 dimensions know it to be real. Now imagine ourselves as Flatlanders of a higher order, blind to the curled geometries pressing against us. String theory whispers, just because you cannot move through them does not mean they are not there. But the ally does not give its gift without cost. String theory is labyrinthine, filled with equations so complex they sprawl across chalkboards, consuming lifetimes. The landscape of possible hidden dimensions is so vast, perhaps 10 to the power of 500 different shapes, that predicting our own universe within it becomes almost impossible. It is as if we have found a library with infinite books, each describing a different cosmos, but we do not yet know which book is ours. This is the nature of allies in any journey. They empower, but they complicate. They bring clarity and confusion at once. String theory illuminates dimensions, but also multiplies them to dizzying heights. It promises unity, but dangles it always just beyond reach. And still, the pull is irresistible. For physicists, it is not only about proving string theory true, it is about the vision it offers. That reality is not 3-dimensional, not 4, but a grander architecture where hidden dimensions sing the universe into being. It is about the courage to follow the mathematics even when the path is dark, even when evidence is silent. This is where the seeker now finds themselves, guided by allies of elegance and theory, tested by the demand for faith in what cannot yet be seen. The tests multiply. Experiments at the Large Hadron Collider search for evidence of energy leaking into hidden dimensions. Precision measurements probe for tiny deviations in gravity at short distances. Astronomers scan the cosmos for echoes that might betray unseen geometries. So far, the results are null, the hidden dimensions still silent. But silence does not mean absence. It may mean that the scale is too small, the signs too subtle, the doors not yet opened. After all, Flatlanders would never see the 3rd dimension unless they found a way to step beyond their plane. Perhaps we are the same, awaiting the breakthrough that will let us glimpse beyond our slice of reality. And so the seeker walks deeper into the labyrinth, guided by allies whose faith lies in mathematics, tested by the demand for evidence that refuses to appear. The dimensions whisper from the edges of theory, unseen but unavoidable. The threshold has been crossed, the allies are gathered, the tests await their outcome. And the question lingers, sharper now than before. If these extra dimensions are real, why do they remain hidden? What is it that veils them from our eyes? Every journey reaches a point where the seeker draws close to the hidden heart of the mystery, the inmost cave. For dimensions, that cave is not a cavern of stone, but a realm of shadows, projections, and illusions. It is the place where what cannot be seen is hinted at by what can, where higher realities press against perception, leaving only ghostly traces. To understand this, imagine again the parable of Flatland. The two-dimensional beings cannot step into the third dimension, but they can glimpse its shadow. A sphere passing through their plane appears first as a point, then as a growing circle, then shrinking again before vanishing. They cannot perceive the sphere itself, only the slices it casts into their world. To them, the higher reality is incomprehensible, but its shadow is undeniable. What if we are the same? What if higher dimensions exist beyond our perception, but we encounter them only in projection? Mathematics gives us the tools to imagine this. Consider the tesseract, a four-dimensional cube. Just as a cube is the three-dimensional extension of a square, a tesseract is the four-dimensional extension of a cube. We cannot see it directly. Our minds are too bound to three dimensions, but we can glimpse its shadow. A cube within a cube, connected by strange, slanted edges. To us, it looks distorted, impossible. But to a being in four dimensions, it would be as ordinary as a box. This is the cave we now approach, the realization that what we perceive as distortion, impossibility, or abstraction may in fact be the shadows of higher structures. Physics itself hints at this. When particles behave in ways that seem inexplicable, when forces bend and twist as if leaking into unseen corridors, we may be witnessing projections of dimensions we cannot enter. Think of gravity. It is weaker than the other fundamental forces by an absurd margin, a trillion times weaker than the strong nuclear force. Why? Physicists have long puzzled over this disparity. One speculative answer is that gravity seeps into higher dimensions, diluted as it spreads beyond the three spatial axes we know. What we experience may only be its shadow, faint and weakened by the geometry of hidden spaces. Or consider the quantum world, where particles exist in superpositions entangled across distances, appearing and vanishing in ways that defy classical intuition. Could these phenomena be shadows of higher dimensional order? To us, they look random, impossible, spooky. But to a vantage point in higher space, they may be as natural as the rising and setting of the sun. The cave is filled with these shadows. String theory's curled Calabi-Yau spaces, projected into our three dimensions, appear as intricate lattices of holes and folds. The holographic principle, which suggests that our universe may be a lower dimensional projection of a higher dimensional reality, casts the entire cosmos as a shadow on a distant screen. Even black holes, with their event horizons encoding information on surfaces, whisper of dimensional tricks, of realities where depth collapses into area. But approaching the cave also means confronting fear. For shadows unsettle us. They reveal without revealing, hint without clarity. They force us to admit that our perceptions are not sovereign, that we may be fumbling in a dim chamber, while realities beyond shine unseen. To enter the cave is to accept ambiguity, to live with the possibility that our entire cosmos is a shadow world. Philosophers have long felt this unease. Plato's allegory of the cave describes prisoners chained so they see only shadows cast on a wall. To them, the shadows are reality. They cannot turn to see the fire that casts them, nor the objects that pass before it. Only the shadows are real to them. We, perhaps, are those prisoners still. Our senses show us three dimensions and one time, and we mistake them for the whole. But the true fire, the higher geometry, lies beyond our reach. And yet, shadows are also guides. The prisoner who escapes Plato's cave follows the shadows back to their source and discovers the larger truth. In the same way, physics uses the distortions, the anomalies, the shadows of higher dimensions to trace their outlines. When an equation suggests unseen geometry, when an experiment hints at missing energy, we may be catching glimpses of the fire. Shadows are frustrating, but they are also invitations. As the seeker approaches the inmost cave, the question grows sharper. What is real, the shadow or the source? If we cannot perceive higher dimensions directly, but only through their projections, can we ever claim to know them? Or will we forever be flatlanders, mistaking circles for spheres, projections for reality? This is the philosophical weight of dimensions. They force us to confront the limits of knowledge. Science thrives on observation, but dimensions beyond 3 cannot be observed in the ordinary sense. They can only be inferred, hinted at by mathematics and shadows. This is both exhilarating and terrifying. It means we may be brushing against truths that transcend perception itself. The inmost cave is always a place of trial. To approach it is to feel disoriented, to lose the comfort of certainty. For shadows do not answer, they only deepen the questions. But that is why the cave matters. It is here that the seeker must confront the possibility that reality is larger, stranger, and less knowable than we ever dreamed. And yet, the shadows persist. They beckon us forward. They say, there is more. You cannot see it, but you can sense its presence. You cannot grasp it, but you can trace its outlines. The cave is dark, but not empty. The walls are lined with shadows of higher worlds. The seeker stands at the threshold, peering into this abyss. To go further is to face the ordeal, the direct confrontation with the question of how dimensions can exist if they are forever hidden. It is to test whether the shadows lead to truth or to illusion. And so the cave whispers the question we cannot escape. If we are seeing only shadows, how do we ever find the fire? Every quest reaches its darkest trial, the ordeal where the seeker faces the hardest questions head-on. For dimensions, that ordeal is simple to state but nearly impossible to resolve. How do we test what we cannot see? If higher dimensions exist, can we catch them in the act? Or will they forever elude our instruments, leaving us with only shadows and speculation? This is the crucible of physics. For mathematics, no matter how beautiful, must bow before experiment. Equations may predict, analogies may inspire, but without evidence, dimensions remain ghosts. And so, in laboratories and colliders across the world, physicists have undertaken one of the most daunting tasks imaginable, to force the universe to reveal its hidden scaffolding. The first approach was gravity. Among the 4 fundamental forces, gravity is the strangest. It is immeasurably weaker than the others. You can lift a paperclip with a small magnet, overcoming the gravitational pull of the entire Earth. Why should this be? Why should gravity, the force that sculpts galaxies and bends spacetime itself, be so feeble compared to electromagnetism or the strong nuclear force? One possible answer lies in higher dimensions. What if gravity leaks? Imagine that all the familiar forces are confined to our 3-dimensional world, but gravity alone is free to wander into hidden corridors beyond. What we feel then is not the full force of gravity, but only its diluted shadow, spread thin across unseen dimensions. To test this, physicists devised exquisitely delicate experiments. They suspended tiny metal spheres and measured their attraction at distances smaller than the thickness of a human hair. If gravity weakened faster than Newton's law predicted, it might signal the presence of extra dimensions swallowing some of its pull. These tabletop tests pushed the limits of precision, but the results so far have been stubbornly ordinary. Gravity behaved as expected, at least down to the tiniest scales probed. The higher dimensions, if they exist, remained silent. The ordeal deepened at particle colliders. The Large Hadron Collider, LHC, near Geneva, smashes protons together at energies never before achieved, recreating conditions close to the Big Bang. If hidden dimensions are real, the violence of these collisions might reveal them. How? By producing exotic particles that vanish into higher space, leaving behind missing energy, or by generating microscopic black holes that would evaporate in bursts of radiation, their very existence proof of extra dimensions shaping gravity at small scales. The experiments were tense, filled with anticipation. As the LHC roared to life in 2010, some whispered that it might even destroy the Earth, collapsing it into a higher dimensional singularity. Those fears were unfounded, but they revealed the scale of the ordeal. To summon higher dimensions, we had to collide matter at energies that bordered on the terrifying. And yet, as the data poured in, no dimensions appeared. No black holes, no unexplained energy losses, no footprints of hidden corridors. The ordeal ended not with revelation, but with silence. This is the agony of the seeker, to brave the darkness and find no torch waiting. Physics demands courage, but it also demands patience. The ordeal does not always yield answers. Sometimes it leaves us staring into the abyss, wondering whether the shadows were ever there at all. But the trial is not over. Other experiments continue. Astronomers probe the cosmos for hints of dimensions written into its vastness. Could gravitational waves, ripples in spacetime detected by LIGO, leak into higher realms and fade faster than predicted? Could the patterns in the cosmic microwave background, the faint afterglow of the Big Bang, carry imprints of hidden geometries at the dawn of time? These questions drive new missions, new detectors, new eyes on the sky. The ordeal also reveals the limits of our tools. We may simply lack the energy to probe the scales where extra dimensions hide. If they are curled up as Klein imagined, their size could be as small as the Planck length, 100 billion times smaller than an atom. To glimpse them directly may require machines larger than planets, or technologies beyond imagination. The seeker has courage, but even courage must bow to practicality, and so the ordeal becomes philosophical as well as experimental. If dimensions cannot be tested, are they real? Or are they scaffolds of mathematics, useful fictions that guide our equations but do not exist in nature? This is the central tension of the ordeal, to demand proof where proof may forever be beyond reach. To wrestle with the possibility that the ultimate truths of reality may remain hidden no matter how deep we dig. The seeker in this cave faces despair. The path forward is uncertain. The allies of mathematics promise grandeur, but experiments return only silence. The ordeal tempts us to turn back, to declare dimensions fantasy, to retreat into the safety of what we can see. And yet, the ordeal also transforms, for it reminds us that reality is not obligated to yield its secrets easily, that the very difficulty of testing dimensions is itself a clue to their nature. If they are hidden well. If they are real, they shape the universe in ways subtle enough to evade detection. This too is part of the story. Truth must be earned, and the universe does not give it cheaply. The seeker emerges from the ordeal chastened, but not broken. The higher dimensions remain out of reach, but the hunger to know them burns brighter. Failure is not the end, but the proof that the question is worth asking. And so we leave the ordeal with the question unresolved but sharpened. If higher dimensions exist, we may never see them directly. We may only ever glimpse their shadows in gravity's weakness, in particle collisions, in the faint patterns of the cosmos. But shadows are not nothing. Shadows are invitations. The seeker moves on, bearing the weight of the ordeal, ready for the reward that follows. For even if experiments have not revealed dimensions, the theories built upon them have reshaped our vision of the universe in ways that cannot be undone. The ordeal has passed, the seeker lives, and now the glimmer of reward beckons. Every seeker who survives the ordeal emerges with something gained, not always the treasure they sought, but a boon nonetheless. For dimensions, the ordeal of experiment may have yielded silence, but the reward lies in how higher dimensions have reforged our physics, reshaping the very way we imagine the universe. The gift of dimensions is unity. From the time of Newton, physics was a patchwork quilt. Gravity on one side, electromagnetism on another, quantum forces stitched haphazardly across the seams. Each worked in its domain, but together they resisted harmony. Higher dimensions offered a way to bind them into a single fabric. Kaluza-Klein first hinted at this, showing how a hidden dimension could transform electromagnetism into geometry. String theory amplified it, demanding extra dimensions as the stage upon which all forces play. In this framework, every particle, every force, every vibration of matter is a consequence of strings resonating in multidimensional space. The photon, the electron, the quark, all different notes in the same cosmic symphony. The reward is not proof but vision, a universe where diversity emerges from unity, where dimensions are the loom upon which existence is woven. This vision solves puzzles that once seemed insurmountable. The strong nuclear force, the weak nuclear force, electromagnetism and gravity all appear as different manifestations of geometry in higher dimensional space. The standard model, messy and fragmented, suddenly feels like a shadow of something cleaner, more elegant. Even anomalies, like the cosmological constant or the mass of the Higgs boson, may find explanation in the hidden folds of extra dimensions. And the reward does not end with unity. It stretches outward to the cosmos itself. Dimensions, whether hidden or emergent, shape the architecture of reality at every scale. They dictate how galaxies form, how black holes collapse, how the universe expands. If the extra dimensions are curled in particular ways, they may even explain why our universe has the constants it does, why gravity is weak, why atoms are stable, why stars burn as they do. Imagine it. Every breath you take, every photon that reaches your eye, every atom in your body is not only a consequence of physics, but of the hidden geometry of dimensions you cannot see. To live is to inhabit a shape far greater than yourself. The reward also reshapes philosophy. Dimensions force us to confront the question of what real means. If higher dimensions exist but are forever hidden, are they real in the same sense as length or width? Or are they abstractions, convenient scaffolds for our equations? Perhaps reality is not about what is visible, but about what explains. If the unseen dimensions unify the forces of nature, if they predict the particles we observe, if they make the mathematics work, then perhaps that is reality enough. This challenges our instincts. We crave evidence, direct and tangible. But physics has taught us humility before. Atoms were once abstractions, inferred but unseen. Black holes were once mathematical curiosities, doubted even by Einstein. Today they are photographed and measured. Perhaps dimensions too will one day step from abstraction into evidence. Until then, the reward is trust. Trust in the power of mathematics to illuminate truths our senses cannot grasp. And yet, the reward carries shadows. Unity through higher dimensions has not yet delivered the decisive proof physicists yearn for. String theory, with its vast landscape of possible solutions, risks being too flexible, explaining everything and therefore nothing. Critics argue that dimensions may be mirages, mathematical illusions mistaken for reality. The seeker must accept this ambiguity as part of the gift. Knowledge is never pure, and rewards are often double-edged. But ambiguity itself can be a kind of treasure. It teaches us to live with uncertainty, to embrace questions that may never be fully answered. Dimensions remind us that reality is not obligated to be simple, that the universe may be far stranger than our minds can hold. This humility is itself a reward, tempering our arrogance with awe. The seeker also receives another boon, a new way of seeing themselves. If dimensions shape the universe, then they shape us as well. Our atoms, our bodies, our thoughts are consequences of multidimensional geometry. We are not merely inhabitants of three-dimensional space. We are shadows of higher order, ripples in a fabric that extends beyond perception. To ask whether dimensions are real is also to ask whether we ourselves are real, or whether we are projections, fleeting intersections of something deeper. And still the questions multiply. If extra dimensions explain the forces of nature, could they also provide pathways to phenomena we can scarcely imagine? Wormholes connecting distant regions of space, parallel universes stacked beside our own. The possibility of travel, not by crossing space but by slipping into dimensions that bypass it altogether. The reward is not only knowledge but imagination, a widening of the horizon of possibility. It is no accident that science fiction seizes upon dimensions as a source of wonder. They are at once scientific and mythic, rigorous and dreamlike. They allow us to envision realities beyond the familiar, to imagine what lies just outside perception's reach. The reward of dimensions is not only what they explain, but the visions they inspire. Visions that drive new questions, new experiments, new courage to press deeper into the unknown. The seeker emerges from the ordeal transformed. The silence of experiments has not ended the quest. The gift of dimensions is too powerful, too compelling to abandon. They have reforged physics, unified forces, reshaped cosmology, challenged philosophy, and expanded imagination. They have given us a new vision of reality, one where what we see is only the surface of a deeper, richer architecture. This is the reward, not certainty, not proof, but vision, a glimpse of the infinite scaffolding that may underlie existence, a reminder that the universe is not only stranger than we know, but stranger than we can know. And yet, even as the seeker claims the reward, the road back begins to call. For every boon brings new questions, new trials. If dimensions have reshaped our vision of reality, how do they reshape our story of ourselves? If they echo in physics, do they echo in myth, in culture, in the deepest recesses of human imagination? The seeker has won the reward. But the journey is not done. The road back awaits. Every hero's journey must circle back toward the ordinary world, carrying the treasure found in darkness into the realm of the familiar. For dimensions, that road back runs through more than physics. It winds through the oldest myths of humanity, through visions and symbols that long predate Einstein, Kaluza, or string theory. For if higher dimensions are real, or even if they are only the language of our imagination, then they have always been with us, hidden in the ways we dream, the myths we tell, the mysteries we seek. Physics has given us equations, geometries, and theories, but before physics, there were stories. The human mind has always imagined realms beyond perception, other worlds layered beside or above our own. We may call them heavens, underworlds, spiritual planes, or dreamscapes, but the impulse is the same, to sense that reality extends beyond the three dimensions of ordinary life. Ancient cultures spoke of worlds stacked upon each other like hidden floors of a cosmic structure. In Hindu cosmology, there are multiple lokas, realms of existence layered beyond ordinary perception, accessible only through spiritual practice or death. In Norse mythology, Yggdrasil, the world tree, binds together 9 realms, each with its own laws and inhabitants. In Plato's philosophy, the cave allegory suggests that what we see are shadows, projections of higher forms. Each myth, each vision, echoes the idea that our perceived world is not the whole, but a slice of something greater. Is it coincidence that these stories resonate so closely with the language of physics? Or is it evidence that humans, long before science, sensed the limits of their perception and invented symbols to express it? The physicist speaks of curled Calabi-Yau manifolds, while the mystic speaks of hidden heavens. Different tongues perhaps, but aimed at the same horizon. The road back also reveals how deeply the idea of dimensions has shaped culture. In the 19th and early 20th centuries, as mathematics explored higher spaces, spiritualists seized upon the fourth dimension as proof of their visions. They claimed that ghosts, spirits, and other supernatural phenomena might exist in dimensions beyond our own, brushing against us unseen. Even artists absorbed the imagery. Cubism fractured perspective as if to capture multiple dimensions on a single canvas. Writers like H.G. Wells and Madeleine L'Engle imagined travel through the fourth dimension as a means of transcending space and time. The language of physics bled into myth, and myth bled back into culture. Skeptics dismiss this as coincidence, as metaphor mistaken for truth. And perhaps they are right. The realms of gods and spirits are not the same as curled geometries or holographic projections, but the resonance is undeniable. Humans seem drawn to the idea of hidden layers of reality, of dimensions that conceal mysteries beyond sight. Whether in myth or in science, the instinct is the same, to suspect that the visible world is only a surface and that behind it lies depth. But the road back is never without danger, for myth and mysticism can blur into pseudoscience, leading seekers astray. The temptation to conflate spiritual planes with physical dimensions is strong, but it can weaken both science and myth by confusing their roles. The physicist's task is not to confirm heaven or hell, but to describe geometry and forces. The mystic's task is not to measure gravity, but to explore meaning. To collapse them into one risks losing the clarity of both. And yet we should not dismiss the echo too quickly, for myths often carry truths in symbolic form. Just as ancient sailors spoke of sea monsters to represent the unknown dangers of the ocean, so too might ancient stories of hidden realms reflect an intuition. That perception is limited, that reality extends beyond what we see. Perhaps myth is not physics, but it is philosophy. It whispers that the world is deeper than it appears, that dimensions may always lie beyond our grasp.
The road back reminds us of our continuity with the past. Physics may use equations now, but the hunger that drives it is ancient. The same awe that inspired shamans, mystics, and poets now inspires particle physicists and cosmologists. We are all staring into the same abyss, asking the same question: is this world all there is, or does something greater surround it?
And in this echo lies a warning. Myths endure because they satisfy a need for meaning. Physics must be careful not to strip away mystery so thoroughly that it leaves only emptiness. The reward of higher dimensions is not only unification of forces, but restoration of wonder. Science and myth, if kept distinct but parallel, can guide each other, myth reminding science of awe, science reminding myth of rigor. The seeker walking the road back begins to sense this duality. On one side are the equations of physics, abstract but powerful. On the other are the stories of humanity, symbolic but resonant. Between them lies the recognition that dimensions are not just a scientific question, but a human one. They shape not only how we measure the cosmos, but how we imagine it, how we place ourselves within it. The road back is not a retreat to the ordinary world. It is a return enriched, carrying the elixir of knowledge to those who remained behind. The seeker returns with a story, that higher dimensions may exist not only in equations, but in the deepest corners of the human imagination. That we are not the first to suspect hidden layers of reality. That our ancestors, in their myths, were already whispering of dimensions long before science gave them a name. But the return also raises a new question. If dimensions echo in myth and science alike, what are they really? Are they physical structures unseen but measurable? Or are they metaphors for limits of perception, symbols for the unreachable? The road back offers no simple answer. It offers only the realization that dimensions, whether real or imagined, are inescapable. They haunt both physics and philosophy. They bind together the past and the present, myth and science, imagination and measurement. And so the seeker, carrying the reward of vision, approaches the final stages of the journey. Ahead lies resurrection,
the moment when the hidden becomes manifest, when simulations and calculations resurrect dimensions in forms we can grasp. Beyond that lies the final boon, the synthesis of knowledge and wonder. But for now, the road back is enough. The seeker walks in two worlds, the scientific and the mythic, the measured and the imagined.
For dimensions are not just a question of physics, they are a question of humanity itself. Every hero's journey brings the seeker to resurrection, a moment when what was thought lost is made manifest again, when hope long buried is revived in unexpected form. For dimensions, that resurrection comes not through ancient myth, nor through direct experiment, but through the cold precision of mathematics and the raw power of computation. For decades, higher dimensions lived in the shadows, elegant in theory, but absent in proof. String theory demanded them. Kaluza-Klein hinted at them. Yet experiments, as we saw, returned silence. The ordeal was endured, but the seeker seemed empty-handed. Then, in the late 20th century, physicists began to resurrect dimensions in a new way, not in hidden corridors of stone, but in grids of numbers, simulated universes built on the world's most powerful computers. This resurrection is lattice gauge theory, better known as lattice QCD. QCD, quantum chromodynamics, is the theory of quarks and gluons, the particles that make up protons and neutrons. It is an unforgiving theory, defined by the strong nuclear force, where equations spiral into chaos and cannot be solved with pencil and paper. To glimpse its truths, physicists turned to simulation. They placed quarks on a lattice, a four-dimensional grid of space and time, and calculated how gluons weave between them. And what emerged from these simulations was a resurrection. Higher dimensions made visible, not in reality itself, but in virtual form. The gluon fields traced invisible tubes of force, flux lines snapping like elastic bands when quarks were pulled apart. The hidden dimensions of the theory became manifest in the lattice. The shadows grew flesh, even if only in numbers. This was resurrection in the truest sense. Dimensions that seemed forever unreachable could be glimpsed indirectly, their fingerprints left in the patterns of quarks and gluons. The mathematics that once whispered of hidden corridors could now be tested step by step against the behavior of real particles. The dimensions were no longer fantasies, they had become computationally tangible. But the resurrection did not end with quarks and gluons. In the 1990s, another vision emerged, the holographic principle. Sparked by the paradoxes of black holes, it suggested that everything within a volume of space could be described by information encoded on its boundary. A three-dimensional world might be the projection of a two-dimensional surface. Dimensions, once thought fundamental, might themselves be illusions, emergent properties of information, shadows of a deeper reality. Here, resurrection takes a paradoxical form. Higher dimensions may exist, but they may not be fundamental. They may be like the surface of a pond, rippling into appearance from something deeper and stranger. Our three-dimensional universe may be a hologram, a projection from a more basic reality. Dimensions are real, but not ultimate. They are resurrected, but transformed. This revival is unsettling. It suggests that what we take for granted, the solidity of space, the flow of time, may be derivative, not foundational. That we are not inhabitants of dimensions, but participants in their illusion. Yet it is also exhilarating. It means that dimensions are not static but dynamic, not fixed but emergent. They live, die, and rise again in different guises depending on the level of reality we choose to examine. Resurrection also comes in the form of cosmology. The early universe, moments after the Big Bang, may have been shaped by extra dimensions that later curled up or vanished from our perception. Some cosmological models suggest that our universe is a three-dimensional brane, a membrane floating in a higher dimensional space, colliding with others in a multiverse. If true, then dimensions themselves are reborn with every cosmic cycle, inflating, collapsing, resurrecting across eternity. The seeker, who once despaired in the ordeal, now sees life returning to the question. Dimensions, though elusive, refuse to stay buried. They rise again in simulations, in holograms, in cosmology. They refuse to die because they are too deeply entwined with the structure of reality. Even if unseen, they shape what we see. Even if unmeasured, they shape what we measure. And in this resurrection lies transformation, for what is revived is never the same as what was lost. Dimensions once thought of as simple scaffolding, up, down, forward, back, now appear as something fluid, emergent, malleable. They may not exist as things at all, but as consequences of deeper structures. Their resurrection teaches us that reality is not built on bedrock, but on shifting sands of mathematics, information, and possibility.
The seeker, now changed, realizes that the question itself must be rephrased. It is not simply, are dimensions real? But what does it mean for dimensions to be real? If they can emerge from holograms, collapse into branes, be simulated on lattices, then perhaps reality is not about permanence, but about resurrection. Perhaps dimensions are real because they can be revived, reshaped, and reimagined.
This is the gift of resurrection, not certainty, but renewal. Dimensions do not need to be proven once and for all to matter. Their power lies in how they return again and again, across theories, across experiments, across the very history of physics. Each resurrection deepens our understanding, even if it does not close the question. And yet, as with all resurrections, shadows remain. If dimensions are emergent, what are they emerging from? If they are projections, what is the projector? If they are illusions, who or what is being deceived? The seeker, revived but not satisfied, must carry these questions forward. Resurrection is never the end. It is the beginning of the return. The seeker must carry the elixir of knowledge back to the ordinary world, to share it with others, to reshape the story of who we are. But before that return, there are trials still to come, interpretations to battle, truths to weigh. For now, though, the seeker stands in awe of what has been revived. Dimensions once doubted, once dismissed, have risen again in simulations, holograms, and cosmology. They are alive, even if only in whispers. They will not be silenced. The seeker has witnessed resurrection, and with it comes a sobering realization. If dimensions can be resurrected in so many guises, then perhaps they are not illusions at all. Perhaps they are eternal, waiting to return in whatever form we are ready to see. But what elixir do they offer? What truth do they carry back to the ordinary world? That is the next stage of the journey. The seeker now carries the elixir, the hard-won knowledge born from ordeal and resurrection. It is not the simple treasure of certainty. It is subtler, more unsettling. The realization that dimensions may not be truths carved into the fabric of reality, but tools, frameworks we use to interpret the cosmos, scaffolds we erect to hold up our understanding. This is not the elixir we expected. We longed for a definitive answer, for a triumphant declaration. Yes, dimensions exist in their hidden majesty, or no, they are illusions of mathematics. Instead, we return with something deeper, humility. The lesson that dimensions are perhaps less about reality itself and more about how our minds engage with reality. For centuries, dimensions have served as humanity's way of ordering experience. Euclid gave us 3 dimensions of geometry, axes upon which to chart the physical world. Einstein added time, transforming the universe into spacetime, a continuum where gravity became curvature. Theorists after him added more, curled, compact, hidden dimensions, not because experiments demanded them, but because mathematics suggested they might unify what was otherwise fragmented. Dimensions in this light are not simply discovered, but invented. They are not only out there waiting to be measured, they are also in here, in the mind, constructs that give shape to chaos. They are tools, not truths. This is not to diminish them. Tools can be powerful, even world-changing. The concept of 3 dimensions built bridges, cathedrals, and machines. The 4th dimension of time gave us relativity, GPS, and the bending of light by stars. Even the unproven dimensions of string theory inspire new experiments, new mathematics, new visions of what may be possible. The elixir is that dimensions guide us forward, even when their ontological status remains in doubt. But this tool-like nature also reframes the question. When we ask, are dimensions real? We may be asking the wrong thing. The better question may be, are dimensions useful? Do they explain? Do they predict? Do they allow us to see what we could not see before? Reality in physics is often judged not by metaphysical certainty, but by utility. Electrons are real because they explain and predict phenomena with extraordinary precision, not because we can hold them in our hands. Dimensions may be real in this same pragmatic sense, and yet there is danger in this elixir too. For if dimensions are only tools, then the universe may be stranger still than we dare to imagine. What lies beyond the tool? What structure does reality take if not dimensional? Could there be frameworks beyond geometry, beyond space and time altogether, that our minds are not yet equipped to grasp? Here lies the humility. The elixir reminds us that human thought is bounded. We invent coordinates, axes, grids, projections, because that is what our brains can manage. But the universe is under no obligation to obey our categories. It may transcend them entirely. We may be like fish describing the ocean in terms of length, width, and depth, unaware that air exists above the surface. The seeker, carrying the elixir, must bring this lesson back to the ordinary world, to remind us that dimensions are not certainties, but invitations. They are ways of reaching toward the real, not the real itself. They are bridges between ignorance and insight, fragile but necessary. They are stepping stones across a river we may never fully cross. And this elixir transforms how we live, for it teaches us to see the world not as fixed but as layered, provisional, open-ended. It teaches us to embrace the provisional nature of knowledge, to accept that truth may be less about possession and more about pursuit. It teaches us that reality may always outrun our tools, but that our tools are enough to keep us chasing. This is the gift dimensions bring, not closure but wonder, not truth but humility, not finality but endless beginnings. The seeker has returned with the elixir, but trials remain, interpretations to face, rival visions to confront. For not all agree that dimensions are tools, some insist they are truths, others deny them altogether. Ahead lie the trials of interpretation, the battles that will decide how or if dimensions endure in our understanding. The seeker carrying the elixir does not return to peace. Instead, they find a battlefield of interpretation where rival visions clash. Dimensions, though elegant and powerful, face fierce opposition. Some argue they are illusions, artifacts of human mathematics. Others propose rival frameworks, visions of reality that bypass dimensions entirely. Here the seeker must endure the trial not of discovery, but of meaning. The first challenge comes from emergent theories. In recent decades, physicists have dared to suggest that space and time themselves may not be fundamental. Instead, they could emerge from networks of quantum information, from entanglement woven into patterns far deeper than geometry. If so, then dimensions are not the bedrock of reality, but a mirage, the large-scale appearance of something more primal. In this view, dimensions are like temperature, real in daily life, but emergent from countless microscopic interactions. This trial strikes at the heart of the elixir. If dimensions are tools, they may not even be the most essential ones. They may dissolve under closer scrutiny, replaced by concepts beyond human intuition. Another challenge rises from loop quantum gravity, a rival to string theory. It proposes that spacetime is not continuous but granular, built from discrete loops of energy. Here, dimensions are not infinite scaffolds but approximations, breaking down at the smallest scales. If this vision is correct, then dimensions as we know them are convenient fictions, crutches that collapse when pressed too far. And then there are interpretations that reject dimensions altogether. Some philosophers of science argue that geometry is nothing more than a map of relationships, not a real structure. In their view, space is not a container, but a web of interactions. What we call dimensions are simply labels we assign to order the web. Reality itself may have no dimensions at all, only relations, patterns, connections. The trial intensifies with the specter of the multiverse. Some models of cosmology suggest countless universes, each with different numbers of dimensions, some with 2, some with 10, some with none at all. If this is true, then our universe's 3 spatial dimensions are not fundamental but contingent, accidents of cosmic lottery. They are not truths about reality, only features of our particular corner of it. This shatters the dream of universality. Dimensions may not be eternal laws but local quirks. The seeker must endure these blows. Each one chips away at certainty, each one forces a confrontation with humility. Dimensions, once thought firm, dissolve into possibilities. The elixir trembles under scrutiny. Can dimensions survive this trial? Perhaps, for even as interpretations clash, dimensions prove resilient. They continue to explain, to predict, to guide experiments. They remain indispensable in practice even if their metaphysical status is questioned, like a compass that works even if the Earth's magnetic field is not fully understood. Dimensions orient us, even if they are not ultimate truths. The seeker learns here the hardest lesson. Truth in science is not a monolith, but a battlefield. Theories compete, interpretations diverge, and certainty is rare. Dimensions may not be the final word, but they remain one of the strongest contenders. The trial does not destroy them, but it scars them, tempering them like metal in fire. And from the fire comes clarity. The very fact that dimensions inspire such debate is proof of their power. Few ideas could command both reverence and skepticism for centuries. Few could survive being challenged by myth, mathematics, experiment, and philosophy, and still remain central to our quest. The seeker endures the trial. The elixir, though battered, still glows. And ahead, at last, lies the boon, the ultimate reward of seeing dimensions not as mere geometry, but as a profound metaphor for unity itself. The seeker, scarred but unbroken from the trials of interpretation, now approaches the ultimate boon. What lies ahead is not a final equation, not a definitive measurement, but something deeper. The realization that dimensions are more than scaffolds of physics. They are symbols of cohesion, metaphors of unity, bridges between the seen and unseen. In them, science and philosophy converge, not in certainty but in meaning. Dimensions unify. That has always been their promise. In physics, they tie disparate forces into a single fabric. Space and time, once thought separate, become spacetime. Gravity, once mysterious, becomes curvature of that continuum. Electromagnetism, once distinct, can be woven into geometry through hidden dimensions. Even string theory, though unproven, uses dimensions to turn chaos into order, countless particles reduced to vibrations of a single kind of entity. The boon is not proof, but coherence. In dimensions, the universe ceases to be a patchwork. It becomes a whole. And beyond science, dimensions also unify human thought. Myth spoke of hidden realms. Mathematics spoke of higher spaces. Mysticism spoke of invisible planes. Physics reframes these in rigorous terms, but the impulse is the same: to seek connection, to suspect that what we see is only the surface of a deeper unity. Dimensions serve as the metaphor that binds. This cohesion is philosophical as much as physical. It reminds us that human beings are pattern seekers, hungry for frameworks that hold meaning together. Dimensions are the language of that hunger. They give shape to mystery, structure to awe. They tell us that there is more than meets the eye, that reality is not fragmented chaos, but ordered, layered, structured, whether in mathematics or myth. The boon is also existential. If dimensions bind the cosmos, then they bind us as well. Our bodies, our thoughts, our histories are not separate from the fabric. They are threads woven into it. To exist is to participate in dimensions, to be enfolded within them. This recognition dissolves the illusion of separateness. It whispers that we are not outsiders observing reality, but part of the very structure that defines it. And yet, the boon is not comfort alone. It also unsettles. For cohesion does not mean simplicity. It means that everything is entangled, that no truth stands alone. If dimensions unify forces, then they also unify mysteries. Dark matter, dark energy, the weakness of gravity, the possibility of multiverses, all of these are tied to the question of dimensions. To accept cohesion is to accept complexity, to embrace the enormity of what we do not yet know. Still, there is power in this. The boon transforms how we approach the unknown. Instead of seeing mysteries as isolated puzzles, we see them as facets of a single, deeper question. The problem of forces, the problem of cosmology, the problem of consciousness, all may be bound, at least symbolically, by dimensions. They are the thread that suggests hidden unity, the sign that our search is not in vain. The seeker, standing at the heart of this realization, feels awe. For the boon is not just scientific elegance, but a philosophical awakening. Dimensions, whether real in a physical sense or not, embody the deepest human intuition that reality is not fractured but whole, that beneath appearances lies cohesion, that mystery itself is structured, and so the seeker receives the ultimate gift. Not proof, not certainty, but vision. The vision of unity through dimensions. It is a boon that changes how we see the cosmos and how we see ourselves. It tells us that our longing for connection, our search for hidden truths, is not folly. It is the very essence of what it means to be human. Yet even as the boon is granted, the circle nears its close. The seeker must return to the ordinary world, carrying this vision not as an abstraction but as a transformation. Dimensions have been explored, doubted, resurrected, scarred, and finally understood as symbols of cohesion. Now the task is to live with that knowledge, to master both worlds, the scientific and the human, the measurable and the meaningful. The ultimate boon has been won, but a final step remains: to achieve equilibrium, to bring the journey full circle, to live in a world forever haunted and enriched by the possibility of dimensions. The journey began with certainty, the ordinary world of 3 dimensions, with time as a familiar fourth, solid, unquestioned, seemingly unshakable. Then came the call to adventure, whispers of hidden corridors, unseen scaffolds shaping reality. We followed that call into ordeal and doubt, into theories grand and experiments silent, into resurrections of mathematics and philosophy. Now, at last, the seeker returns. Not to the world they left, but to a new equilibrium forever changed. For dimensions, whether real or imagined, have done their work. They have reshaped how we see the universe. They have reminded us that reality is deeper than perception, stranger than intuition, grander than imagination. And they have left us with a question that will not die. What binds existence itself? This is the infinite bind. On one side, we cling to dimensions as real. They are woven into equations, into predictions, into the very physics that governs stars and atoms. They unify forces, describe gravity, explain why matter exists at all. Without dimensions, our science falters. In this sense, they are undeniable, as real as the breath in your lungs, as real as the ground beneath your feet. On the other side, dimensions slip through our grasp. Higher ones refuse to reveal themselves in experiments. Some theories whisper that even the dimensions we know are not fundamental, but emergent illusions, shadows cast by deeper structures of information. In this sense, they are phantoms, useful but not ultimate, real but not real enough. And so we are bound, caught between dimensions as truth and dimensions as tool, between certainty and doubt, between geometry and mystery. This is the infinite bind, the equilibrium we inherit. Yet equilibrium does not mean stasis, it means transformation. It means learning to live in a world where dimensions are both scaffolds and symbols, both equations and metaphors. It means holding in tension the scientific and the philosophical, the measurable and the meaningful. This is not a lesser truth, but a greater one, a truth born of humility. For the final revelation of dimensions is not that they exist or do not exist. It is that their very ambiguity reshapes us. They teach us to embrace uncertainty without paralysis, to wonder without surrender, to seek without demanding closure. They remind us that the universe is not a puzzle to be solved once and for all, but a mystery to be lived. In this new equilibrium, we see dimensions everywhere. In the equations of string theory, curling unseen through Calabi-Yau spaces. In the geometry of spacetime, bending under the weight of stars. In the myths of our ancestors who spoke of heavens and underworlds. In the art of visionaries who fractured perspective to glimpse hidden depth. In the very act of thought, which leaps beyond what eyes can see. Dimensions live not only in physics but in us, and they will not leave us. For even if tomorrow's experiments show no sign of hidden corridors, even if new theories abandon them altogether, dimensions will endure. Because they are more than geometry. They are the embodiment of our need to reach beyond. They are the symbol of our refusal to accept that what we see is all there is. They are the language of human longing for the infinite. This is why the journey ends not in despair, but in awe. To walk the path of dimensions is to discover not only the universe's architecture, but our own. We are seekers by nature, restless, unsatisfied, bound to search for deeper truths. Dimensions are the mirror of that nature. They whisper that there is always more, always hidden depth, always horizons yet unseen.
And so the seeker stands at the threshold of a new equilibrium. Behind lies the comfort of certainty, the illusion of a flat, knowable world. Ahead lies the boundless unknown, the infinite bind of dimensions both real and unreal. Between them lies transformation, the recognition that to be human is to dwell in that tension, to live within unanswered questions, to be shaped by mysteries we cannot resolve.
This is the final gift of dimensions. They do not settle the question of reality. They do something greater. They transform how we see reality itself. They remind us that existence is not a solved riddle, but an unfolding journey. They invite us not to mastery, but to humility, not to possession, but to awe. And in that humility lies freedom. For if dimensions are both tool and truth, then we are free to imagine, to explore, to dream. We are free to build new theories, new myths, new visions of what may be. We are free to accept that the universe is larger than our grasp, and that this is not defeat, but wonder. The seeker, now transformed, returns to the ordinary world. But the world is no longer ordinary. Every street, every building, every star is haunted by the possibility of hidden corridors. Every breath carries the weight of unseen scaffolds. Every thought echoes with the question, what dimensions hold me here? This is the new equilibrium. To live as if dimensions are both real and unreal, both certain and uncertain. To live bound and yet liberated by the infinite bind. And so the journey ends as it began, with a question. But now the question is richer, darker, deeper. Not simply are dimensions real, but what does it mean to live in a universe where reality itself resists certainty? The answer is not given. It cannot be. It must be lived. In every experiment, every equation, every story, every act of wonder, the question returns. The circle closes only to open again. Dimensions are real, and they are not. They are truths and tools, shadows and scaffolds. They are the infinite bind that holds us, that shapes us, that transforms us. And in that bind lies our future, For the story of dimensions is not finished. It will continue in new theories, new experiments, new myths. It will continue in the minds of seekers yet unborn, who will ask the same question in new ways. It will continue in you as you step back into your life, haunted by the possibility of hidden realms. The journey is done, the seeker has returned, the equilibrium is found. But the question endures, are dimensions even real? And in that question lies everything. Thank you for joining us on this extraordinary journey through the cosmos here on Frontiers of Infinity. If this glimpse into the unknown has sparked your curiosity, be sure to subscribe and join us each Friday at 7 p.m. Eastern, where we unravel the darkest mysteries of space.